Today's lesson will be about how to find
The greatest
There are at least three ways to find. There are three ways to find the greatest common factor. The first way is the way I was taught. That's to make a list. What I don't like about this is it's time consuming and it's really easy to forget a number. The second way is sort of related to the first, and that's to make a Venn diagram. Now again, you have to list all the numbers involved, so I don't find this to be very helpful. The third way is what you did yesterday for homework, which happens to be my preferred way to do it, which is prime factorization. This way you don't have to list all the numbers. It's really easy to do once you get the hang of it. So let's take a look at the three different ways. The first way is, as I said, make a list. So let's start off with two numbers, 36 and 60. So the factors of 36 are 1, list. Look at all this extra stuff. This is just, and I find it ridiculous. So now I have to match up the numbers. Let's see, they have a common factor of 1, common factor of 2, 3, 4, 5, no, 6, yes, 10, no, 12, yes, 15, no, 18, yes, 20, wait a minute, 18, no, that's not a factor of there. So it must be 12. So then you can organize it using a Venn diagram, assuming you didn't make any mistakes like I did just here. Alright, so the common factors are 1, 2, 3, 4, 6, and 12. The factors of just 36 are 9, 18, and 36. And the factors of 60 are 5, 10, 15, 20, 30, and 60. Seems like a lot of work to me. So, how could prime factorization be a little bit easier? Well, let's take a look. So, using the same numbers, 36 and 60, I have to find the factors of 36. Well, I know 6 times 6 is 36, so I'll just start off with that. 2 and 3 are factors of 6, so those are prime numbers. I'm going to circle those. And that's repeated over here, 2 and 3. So the prime factorization of 36 is 2 squared times 3 squared. Now let's look at 60. I've got 6 on the mind, so I'm going to start off with 6 and 10. Let's see, I know that's 2 and 3 for factors of 6. And 10 would be 2 and 5. Okay. So if I organize this, it's going to be 2 times 2 times 3 times 5, or 2 squared times... Alright, so with greatest common factor here, we have 2 squared times 3 times 5 for 60. Now, what we need to do is find all the common factors and the smallest amounts. So, they both share 2 to the power of 2, so we're going to use 2 squared. They both share 3, but only once, so we can only include that once. And they don't both share 5, so 2 squared is 4 times 3 is 12. I just find that to be a lot easier than all of this. And it's, once you get used to it, it really is almost error-free. Alright, so let's take a look at one more example, doing it all three different ways. Because sometimes it is just easier to make a list. So we'll use the numbers 30 and 24. So the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. So a number like those two numbers, doesn't take a whole lot of time. Sometimes there is an advantage of writing a list. So here we just have to compare the numbers. It looks like 6 is going to be our greatest common factor. We could do a Venn diagram with those as well, but you really end up with the same information, and then you just have to cross-reference it a bunch of times. Factors of 30, factors of 24 over here. 4, 8, 12, 24, 5, 10, 15, and 30. But again, the same thing can be done with prime factorization. If you had 24 and 30, two factors of 24 are 6 and 4. 4 is 2 and 2. And factors of 6 would be 2 and 3. So the prime factorization of 24 is 2 to the third power times 3. And the prime factorization of 30 is 10 and 3. 3 is a prime number. 2 and 5, those are both prime. So it's going to be 2 times 3 times 5. Here I have to look for common numbers that they share. They both have a base of 2, but only 24 has an exponent, so we're not going to include that. If there was an exponent up here, we'd include the one that's the smaller of the two. They both have a base of 3, so we'll include that, and they don't share 5, so our greatest common factor here is 6, which is demonstrated up here with making a list, doing a Venn diagram, not my favorite, and then doing prime factorization, which I find to be the easiest method out of the 3. Really, it depends on how large the number is and how many numbers you're dealing with. If you're dealing with more than 2 numbers, I would definitely go with prime factorization. It just makes it easier. There you have to look at what numbers all 3 are sharing. So let's take a look at one like that really quick. Let's do 90, 54, and 81. Now I certainly wouldn't want to make a list for all 3 of these because it would just be time consuming. So by doing the factors, factors of 90 are 9 and 10. That's 3 and 3. Those are both prime. 2 and 5. So my prime factorization is 2 times 3 squared times 5 for 90. For 54, it's going to be 6 and 9, 2 and 3, and 3 and 3. So I've got 2 times 3 cubed for 54 for prime factorization. And for 81, 9 times 9. I'm just going to cut to the chase here, 3 squared and 3 squared for this, with a total of 3 to the 4th power. So now I need to find out what common factor they have, or greatest common factor. They don't all share a base of 2, so I have to skip that. They have here there's a base of 3, base of 3, base of 3. Looking for the largest exponent, that would be 2. So 3 squared, and only the 90 has a 5. There's no 5 over here, so I'm going to have to skip that. So the greatest common factor for 90, 54, and 81 would be 9. It's that simple.